Hello everyone. For today's seminar, I'm going to talk about the paper ACUEval. This paper discussed more fine-grained paper smoothness evaluation for text summarization, and also how to improve faithfulness by refining summaries. I hope this paper offers insight for your research. Before I leave the paper, I briefly summarize the contribution in this paper. There are three key contributions from this paper. First, they introduce a LLM-based evaluator which outperform previous ones. Their key concept is evaluating at the ACL level, and they observed this kind of granularity lead to better alignment with human. This concept is also related to their second contribution. Most LLM-based methods tend to show a preference bias toward LLM output, but ACUEval can reduce bias. This is the second contribution in this paper. Lastly, utilizing ACU is directly connected to more actionable feedback for text refinement. In most cases, text refinement requires a separate feedback model, but this model don't have clear criteria or explanation about why they fix the output. Unlike this case, ACUEval can provide the specific feedback for factors. I will break down each of these contributions in more detail. Before I explain the method and experiment, I would like to inform the definition of ACU. ACU can improve text evaluation performance by increasing granularity. In many NLP tasks, increasing granularity allows for more precise evaluation. As you can see the slide, evaluating raw model output referred as coarse-grain evaluation. This raw output can be summary or answer to question. If we can break down this output into more small units such as sentence, we can get more detailed information for evaluation. Instead of just saying this output is incorrect, pointing out which sentences are wrong gives us a more informative evaluations. ACU is an advance of this concept, and ACU represents smaller semantic unit than sentence, and it is a similar concept of fact. You can understand ACU as very small factors within a sentence, and it consists of no more than 3 entities. You can see 3 examples in slide. In short, with more fine-grained evaluation, you can give a more detailed explanation of the error in the output. And let's move on to how they use ACU for text evaluation. To prepare for evaluation using ACU, the first step is to generate the ACU. The example in the previous slide is just example created manually, but this kind of task can be replaced by LLM. So the other generate ACU using by Llama 270 billions, they just loaded the checkpoint called stable beluga 2, which was instruction-tuned model in the Hugging Face. They also suggest ACU generation prompt for summary level. In the previous study, ACU generation prompt was already proposed, and it was very simple prompt. The issue here is this prompt was designed for sentence level evaluation, and it may be not fit well for summary level. So the others modified the prompt for summary level. Here is their customized prompt. They just changed the pure example to be at the summary level. The next step is to check whether each ACU in the summary is factually consistent with the document. You can think about this process as classifying the label based on whether hallucination occurs. Just like ACU generation, this is also done through prompting without personalized model. One key difference from traditional fact-checking is that instead of using binary label, they evaluate based on token probability for yes. The binary evaluation score is calculated as the average of the score from all factors. This score means summary level score. This process is also very simple prompting. Input are document and ACU, then evaluator generate the label, but they use just token probability for yes. The final step is refining the summary to correct any error. The refined model rewrites the summary based on the evaluator's detection, and by using ACUEval feedback, the summary can be refined to be faithful. This is the binary prompt used in the paper for text refinement. When you look at the method, it might seem quite simple compared to other deep learning techniques. But many research on LLMs shows that even just incorporating such concept into prompt can lead to performance improvement. So let's check how much these simple prompts and the concept of ACU help by reviewing the experiment result. The table in this slide summarizes the main experiment from the paper. And this is table. They can check balanced accuracy across summarization evaluation benchmark. For example, SUMM and ACUEval. The author also conducted an additional study focusing on evaluation steps. I will explain in the following slides. Before presenting the result, it is important to note that ACUEval calculated using token probability and the binary label is not determined by 0.5. In fact, some other evaluators generate prototype scores, but it is impossible to compute balanced accuracy. So, benchmarking such models requires a process known as threshold selection. This process involves identifying the optimal threshold using ROC curve. Many papers split the data into validation and test set, selecting the threshold based on validation set and then applying it to the test set. ACUEval also followed this process and decide threshold based on the token probability. Although this selection may be considered as strange, it was suggested because it's been observed that each dataset tends to have its own inherent threshold. This figure is example in other paper and shows the threshold selection for two datasets. As you can see, the blue always have lower threshold than orange, and this suggests that dataset might have an inherent upper bound for scores. I would like to remind you that this is not based on any strict theory and it is just observation. Despite this, threshold selection technique is generally used for balanced accuracy, and ACUEval follows this approach as well. Next, here is the table summarizing the evaluation performance of ACUEval. If we apply threshold selection, we generally see that LLM tend to perform worse than non-LLMs in terms of balanced accuracy. As you see this result in the table, even after applying threshold selection, ACUEval shows low performance compared to other models. However, ACUEval always achieves total results across all datasets. Next, I would like to report an interesting contribution regarding ACUEval. One of the advantages that ACUEval is less biased compared to other LLM-based. One of the main issues with automatic LLM evaluator is that they tend to favor LLM output. Essentially, LLM might rate AI output higher than humans. You can see ACUEval show the bias for LLM summary. This can lead to incorrect auto-eval or feedback. But with ACUEval, this issue is addressed. It breaks down sentence into smaller packs, and by doing so, it removes most of external factors like writing style or summary length. So it can provide a much more unbiased evaluation. Additionally, the author conducted an evaluation study on each evaluation step. First, they report loose score between model-generated ACU and humans. They observed that their customized prompt generate more human-like ACU compared to previous ones. But it still does not reach the performance of a fine-tuned and non-LLM like AutoACU. In fact, I think this study is less meaningful than the main studies. This table shows that even though the fine-grained model generated more human-like ACU, it does guarantee better evaluation performance. You can see that when evaluation is conducted with AutoACU, the evaluation performance actually decreases. What is more important is that they didn't test with actual human ACU. This leaves us with some ambiguous point about whether human-like ACUs are more really beneficial. Despite this, using LLM's ACU seems to improve evaluation performance. The next evaluation study focused on evaluating ACU verification. I would like to notice this experiment was designed for just ACU verification. In main part, they checked whether LLM can verify ACU in summary based on document, but in additional study, they check it based on reference summary in the dataset. So the only difference is the reference text. They are just asking, can LLM verify the ACU across different texts? We noticed the similar result here. What's important to think about here is threshold selection. The previous LLM method didn't include this process, but choosing the threshold can improve performance. Given this result, threshold setting can impact the outcome of experiment. Lastly, they calculate the peacefulness scores generated by AutoEval. As shown in the table on the slide, ACUEval style feedback shows superior performance compared to others. This is not only because they refine the output according to specific criterion, but also ACU can provide more fine-grained feedback than other granular units. I believe offering more pinpointed feedback is the key to effective rewriting. Before I finish the presentation, I will summarize the main contribution and address the limitation. ACUEval can offer more accurate and unbiased evaluations, and its feedback is very helpful to enhance refinement performance. However, it remains uncertain whether this advantage extends to long-form generation or other contexts, such as multilingual input. Many recent papers are bringing up similar ideas, so it would be great if you are familiar with ACUs. If you have any questions, please comment on this video. Thank you for listening.